All right, welcome to our last lesson of Unit 1, which is on simplifying radicals. So today we're going to start just with some simplifying of radicals. You may have learned some of these before, which is good. I'm going to go through some that should be review, and I'm also going to show you how to do them. Some of you, if you've learned a different way, that's okay. You can continue to do it the way you learned, but the way I'm going to do it is the only way I'm going to show you, just so that we don't have any confusion. Okay, so first, when we look at a problem like this one, this here is called a radical. That symbol is a radical. A radical, it can be any kind of root. Most commonly we know it as the square root. So the square root, there's a little imaginary 2 right here. We just don't typically write it, and that's why it's called a square root. Eventually we are going to learn about radicals that have a different number there, as well as what that number is called. So for right now, as long as you remember square roots, you'll be fine. So when we have a radical, we have a number inside of the radical. You're going to take that number inside and you're going to make a factor tree. So two numbers that multiply to 25 are 5 and 5. Because we're looking at square roots, see how this number here is a 2 for square roots? And yes, it's imaginary, but it's a 2 there. We're looking for groups of 2 prime numbers. So because I have 2 5s, I bring them out as 1 5. When there's nothing left, your radical goes away and your answer would just be 5. When you have something like the square root of 24, so again, there is a little imaginary 2. We do our factor tree. So 4 times 6, 2 and 2. So this one has a little bit more to our factor tree. And again, it's a square root, so we're looking for pairs. So I have a pair of 2's. I don't have any other pairs because these are different numbers. So the pair of 2's will go outside of our radical. The numbers that did not pair up, we multiply back together and they stay inside the radical. So on this first one, everything paired up and it came outside the radical. Here, not everything paired up, only the 2's paired up. So those come out as a 2, and what's left gets multiplied back together and stays inside. So we're going to do the same thing for square root of 125. So two things that multiply to 125. Let's see, 5 and 25. And then 25 breaks down to 5 and 5. So again, there's a little 2 here. So we're looking for pairs. So I have a pair of 5's, and this 5 is left over. So the pair comes out as a 5. The leftover one stays inside. So your answer would be 5 square root 5. All right, so let's go through. We're going to go through 2 examples here, and we'll finish off the last 2 in class tomorrow. So these are our 4 examples total. We're going to do 1 and 2 right now, and we'll finish off 3 and 4 in class. So these ones that we're going to do in our examples all have a little bit of something added besides just the square root. So the simplifying the square root part, like we did up here, should not have been new. That's something you should have learned in 8th grade and 7th grade. So when we're looking at numbers 1 and 2, you see that we already have on number 1 a number out front. I'm going to just keep that number out front until the very end. So I'm only going to consider my radical at the moment, and I'm going to break it down with thinking about two numbers that multiply to 512. So let's see, what can divide into 512? Dun, 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 4. So what I was doing here is I was using my calculator to just go 512 divided by 2, which does go into 2, but I wanted to try for something bigger. So 512 divided by 3 didn't work. 512 divided by 4, it worked. So 4 and 128. So 4 I know can break down 2 and 2. So now 128. So two things that multiply to 128. So I'm going to do 128. I'm going to try 4 again. So when in my calculator, see, my calculator's right here, I divided 128 by 4 and it went in evenly, 4 and 32. Whoops. I said 2 and I wrote 5. Don't know why I did that. 32. So then 4 will be 2 and 2. Now 32 is one that I know for sure is 8 and 4 because I know my multiplication tables, and then I have 4 and 2, and then I have 2 and 2 again. All right, so this one is a much bigger factor tree. So this -5 on the outside is still going to be on the outside. Okay, I'm just carrying it down. Okay, now I'm looking for pairs because I do have that imaginary 2 there. So I'm going to look for pairs at the bottom of my trees. So there's a pair of 2s, another pair, another pair, another pair. Uh-oh, that 2 didn't have a pair, so that one's going to stay out or stay inside the radical. So again, we're only looking at the bottom of our tree. So I'm looking at all the bottoms. So the bottom here is 2s, 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 and then that bottom had just 1, 2 left. So each of these that I was able to circle, I have 4 circled, so that means I have to have 4 2s that come out. And then that 2 that's left over will stay inside the radical. So once we have that, all of these numbers that are outside now have to get multiplied together. So I have -5 times 2. So -5 times 2 times another 2 times another 2 and times another 2. And that should give us -80 square root 2 as our final answer. So again, that was just the -80 came from multiplying -5 times 2, which is 10. 10 times 2 is 20. 20 times 2 is 40. And 40 times the last 2 would give us our -80. All right. One more example for our notes here. And number 2, you see how we have 2 radicals being multiplied. So how do we combine those to just 1 so it looks like number 1 here? So if you have 2 radicals together being multiplied, you're going to multiply the outside 2 numbers together. So 2 times 3 will get multiplied together. And then inside the radical, you'll multiply 5 times 35. So 2 times 3 is 6. 5 times 35 is 175. Now it looks like number 1. So we can go ahead and do our factor tree. So 175, I know 25 goes into that 7 times, and then 25 goes down to 5 and 5. All right, so my 6 that's outside, I'm just going to copy it down. And then I look for my pairs at the bottom. So I have a pair of 5s. That 7 does not have a pair. So the pair of 5s will come out, as a 5 and the 7 stays inside because it did not have a pair. And I can multiply what's on the outside. So 6 times 5 is 30, square root 7, and we have our answer. All right, so the last two examples we're going to do in class. So if you want to write them down now and try them on your own, you're more than welcome to do so. But we'll finish up those last two in class. So again, come with any questions that you guys still have on radicals, and then we'll finish them up, and hopefully we can get everybody on board with simplifying radicals before Friday is over. If you have any questions, please come ready, and I hope you all have an absolutely wonderful evening.